In this video, we will look at how to compute the time complexity of an algorithm. The time complexity is the amount of time needed or taken by an algorithm to run to completion. The time taken by an algorithm depends on the following components: the compile time and the run time or the execution time. Before we move into details of time complexity, let us look at an example for illustration. Let us consider the task of moving from one location to another. To accomplish this task, assume we have two cars with different capabilities. When the cars move, one car may take less time than the other to reach the destination. In the same way, to solve a problem in computer science, there may be several ways. For instance, these two cars may be considered as two different algorithms, which implements the same operation. Since one car takes less time than the other to reach the destination, similarly, we can say one algorithm may take lesser time to execute than the other. In computer science, the best examples of this scenario are the searching and the sorting algorithms. Let us consider another scenario, where the problem is the same, that is reaching from one location to another. We will now consider two cars of the same model, that is having same capability. But in this scenario, first car is carrying 2 persons and the second car is carrying 5 persons. Generally, but may not be realistic, that the car having lesser persons may reach the destination earlier than the car carrying more persons. In the same way, in an algorithm, the input size matters. That is, we can say that running time of an algorithm is proportional to the size of the input. That is, running time increases with the size of the input. Having seen these illustrations, we will now discuss how to compute the time complexity. The time complexity of an algorithm depends on two components, that is, compile time and the run time or the execution time. We will be concentrating on the running time and are not bothered about the compile time, since the compile time is constant for any algorithm and is dependent on the machines and the compilers or the interpreters. Therefore, in theoretical analysis of time complexity, that is also known as mathematical model, we focus on inspecting the pseudocode, that is, the analysis is performed directly on the description of the algorithm. In theoretical analysis of time complexity, the running time is the number of times the primitive operations are performed by an algorithm. We assume that the primitive or basic operations takes a constant time. The most interesting aspect of the theoretical analysis is the frequency or the number of times the operations are performed. The operations that are considered as primitive or basic operations are declaration statements. The statements that are used to declare variables takes unit of time. Assignment statements. The time taken to retrieve the value or time taken to store the value in the variable is considered to take unit of time. The time required to perform arithmetic operations such as addition, subtraction, multiplication, division, and other elementary arithmetic operations are also considered to take unit time. All the simple arithmetic operations can be accomplished in a unit amount of time. That is, the time taken to fetch the operands and apply the arithmetic operator and to store the result of the arithmetic operation in a variable takes unit of time. The comparison statements, that is, the statements which uses the comparison operations such as less than equal to, greater than equal to, and not equal to, also takes unit time. Accessing elements of the array are also considered as primitive operation and takes unit of time. The time required to call a function is constant and takes a unit of time. In addition, the time required to pass arguments to a function is the same as the time required to store an integer in the memory and takes unit time. The time taken to return the values from a function is also considered to take unit time. So these are the primitive or basic operations that takes unit of time to perform the operations. Then there are iterative statements such as for loop, while loop, and repeat until or do while loops, which performs the operations for number of times depending upon the condition in the loop. Therefore, in theoretical analysis of time complexity, we focus on the number of times the primitive operations are performed by an algorithm to compute the time complexity, and this is known as step count method. The step count method considers the frequency or number of times each operation is executed, and by adding the frequency of each statement, the step count of the entire algorithm is computed. Let us consider this algorithm defined as ABC. This algorithm takes three parameters x, y, and z and evaluates the expression and returns the result. Now this algorithm has only one statement, that is return statement. The return statement is a primitive statement. So the return statement takes a unit time, and this statement only executes once. Therefore, the frequency of the return statement is 1. Now the step count of the entire algorithm is also 1, since there is only one statement which has the frequency 1. Therefore, this algorithm ABC takes unit of time to execute. Now, the number of operations needed to execute an algorithm is represented as a runtime function and takes n as the argument, where n is the input. So, the runtime function of this algorithm is f of n equal to 1. Sometimes, instead of 1, c is used to represent the constant time, and this function is known as a constant function. Therefore, we say that this runtime function or the time complexity is constant. Let us look at another algorithm max and compute its time complexity. This algorithm finds the largest element from the set of elements. Here we have the first statement as result is assigned value a of 1, which takes a unit time since it's an assignment statement. So its frequency is 1. Then the next statement is the for loop. This for statement traverses all the elements in the array. And when there are n elements, then this for loop will run for n times. And in the next loop, the for statement will terminate because the for loop reaches the last element. So this for statement runs for n plus 1 times and its frequency is n plus 1. Then within the for block, we have the if block, which is a primitive statement and takes a unit of time to execute. But since this if block is within the for loop, so this statement or the if block runs for n times, and in the n plus 1th time the for loop terminates, and this statement will not be executed. Therefore, this if block executes for 1 multiplied by n times, and its frequency is n. Then the statement inside the if block, which is the statement result which is assigned the value of a of I, is also a primitive statement. And this statement executes depending upon the condition in the if block. And for the if block, we have already computed its frequency. Then we have the last statement as the return statement, which returns the result. The return statement is a primitive statement. So the return statement will take a unit time, and this statement executes only once. Therefore, the frequency of the return statement is 1. Now, the step count of this entire algorithm is 1 plus n plus 1 plus n plus 1, which is 2n plus 3. Now, the number of operations needed to execute an algorithm is represented as a runtime function, which takes n as the argument. So, the runtime function of this algorithm is f of n equal to 2n plus 3, and 2n plus 3 is a linear polynomial. Therefore, we say that this runtime function or the time complexity of this algorithm is linear, since the leading term of the polynomial has n power 1. So this is how we can compute the amount of time or time complexity of an algorithm.